So when we look at solids, there's two different kinds, and the kinds are based upon the arrangement of the atoms or the molecules inside. So for instance, there are materials where the molecules or the particles are arranged in a very neat, orderly array. And when you have this kind of arrangement, what you have is a crystalline solid. Okay, so for example, things like iron tend to be crystalline. Things like solid water, right, otherwise called ice, tend to be quite crystalline. And if you let things cool down slowly, so if you melt a substance and let it cool down ever so slowly, the particles will often take this kind of crystalline arrangement. Some materials, though, are not this neat and tidy. Some materials are what we refer to as amorphous. And so glasses and tars. So the thing about glass is that if you cool it down relatively quickly, the particles, eventually stop moving and they get frozen out into an arrangement, but the arrangement is a little bit higgledy-piggledy, so there's some sort of short-range order, but in the long scheme of things, right, they don't quite repeat perfectly. So imagine someone's tiled your floor, right, and they haven't really got all the tiles lined up, so this is an amorphous solid, so something like tar or something like glass. So there's a lot of sort of urban legends out there that glass is a liquid. Well, actually, it's not at all. It's not a liquid, but the structure of the molecules themselves, their arrangement might look liquid in the sense that they're not perfectly ordered, but they don't move around. So there's an urban legend that says that if you look at the bottom of windows, it's often a little bit thicker, and that's because the glass has flown down there. And the answer is no, absolutely not. So sometimes the top is thicker, but if you're going to put a glass window, right, or a glass pane up in a window, which end would you want up, right? Which end would you want down? Probably the thicker, stronger one supporting at the bottom, let's say. A thing about solids is that they often have a repeating pattern, and this repeating pattern we can go ahead and kind of break down to its simplest unit, which we call a unit cell. So let's go ahead and take a pattern like so. So these could be molecules, these could be atoms, these could be roses on wallpaper, whatever it may be, but you've got this very nice ordered pattern, and this is two-dimensional, I guess, just because it's easier to draw 2 dimensions than 3 dimensions here on the page. But you can see there's a repeating structure going on here. And let me just go ahead and there we go. That looks pretty good. So we can describe a unit cell. We can describe the repeating pattern here. And I'm just going to go ahead and sketch this in red. And so, for instance, there's a rectangle right there. And I can go ahead and call this the unit cell. So I could take this and I could go ahead and make copies of it. So if I just kind of draw this off to the side, there's my unit cell. It's a square shape. There's something in the middle, and at the edges, right, is 1/4 of this circle. And I can take that unit cell and I can make copies of it, and I can go ahead and reconstruct the original crystal by making these copies. All right, so let's go ahead and grab a copy of this. So I'm going to go ahead and make a copy, and there we go. I'm going to lay it down like so, and I can go ahead and make another copy, and maybe a copy of both those things there, and I can lay them one next to the other, and I can go ahead and make more copies. And as I make more copies, right, I can reconstruct the crystal by basically just repeating that pattern as many times as I like. So these unit cells are the simplest thing that you can use to recreate the structure of the solid.